Assalamualaikum warahmatullahi wabarakatuh and a very good morning everyone. Welcome to our first session of the National Training Week. So we hope that the sessions that we organize will provide valuable insights into the oil and gas industry while we encourage everyone for continuous learning and professional growth. During this session, we encourage everyone to participate actively. Make the most of this opportunity by asking questions, like clarifying facts, any news that you want to know, more opinions from our experienced trainers. Okay, just engage with our trainers. Okay, without further ado, so it is my pleasure to invite our trainer for today's session, Mr. Latif Desa. So the floor is yours, Fatih.
So, I mentioned it. So, the topic actually been slightly changed to give you more understanding about the industry itself. So, apa the understanding of industrial career and the technologies behind the oil and gas development that will cover also petroleum engineering and some other discipline. So, we will cover about 6 modules. Introduction to oil and gas, exploration and geoscience, petroleum engineering, facilities engineering, technology that actually involved, so that you're aware of the new technology that actually change the way we are working. So I think you're aware about the all this artificial intelligence coming in, that you must not be left behind. So keep on be faced with this new technology of artificial intelligence, machine learning, so that whatever scope that you have or in your assignment, you'll be able to do it much better, much more accurate, and more informative in terms of making the decision making. And for the last module, we're going to discuss about the career pathway in oil and gas. So that we have a lot. Okay. So the next one, actually, we start with module 1, introduction to oil and gas. On oil and gas, in terms of the value change, we have what we call upstream, midstream, and downstream, the 3 mainstream. So for us, like in FAAZMIAR technology, company that I'm working now, actually we are involved mostly in upstream. So from exploration, we go down to the, of course, we are not doing that, but we're helping client like Petronas, like, Repsol, or anybody like even some Shell, Mobil, ExxonMobil, just talking about processing or evaluating their seismic results. And then, of course, that once they have decided on that, of course, the next phase, most client or company will start to do the drilling or exploration well. And of course, if they are successful, they're going to do the development wells as well. So after the drilling, they have to go for the production platform, installing production platform. And then, of course, they start to produce from the platform, the hydrocarbon, which is either gas or oil. And as you know, the key player in Malaysia, we have Petronas, Shell, ExxonMobil, PTTEP, as one of the big producer of hydrocarbon in Malaysia. And for upstream, it is talking about transportation and storage. So you can differentiate now. Upstream is talking about exploration drilling, development drilling, and all the seismic, as well as the production of the installing platform for production. But midstream is talking about transportation of that crude, through pipeline, or maybe through we call it all this floating storage, FPSO. And then once you transport that through oil and gas to the pipeline, it will go to the plant, this is processing plant. In Bintulu, they have a LNG plant, which is going to liquidify the gas. And of course, in Miri or Labuan, they have the crude oil terminal, where the oil will go to the onshore, and then from onshore it will be transported to all the refineries and so on. So you can see that for gas, it will be liquefied. The reason of liquefaction actually is to be able to reduce the volume, because the gas volume is huge. You just imagine that, you have 1 liter of gas. When you open up, you can, 1 liter of liquid gas, if you open up, it become almost 600 to 1,000 times in terms of the volume. So that's why in your cooking gas at home, you can see that it's pressurized and it be kept in liquid, and is actually ready to release to gas for your cooking at any time. And just imagine that 1 tank can last about 2 or 3 months, because of the expansion is 600 to almost 1,000 times more than the original volume. So after all the processing, it will go to transportation. If it is gas, it go to the LNG tanker ship to go for sale to to, of course, to Taiwan, to Korea, and then to some other countries, like Japan, exporting. We are exporting our liquid gas to this country. And for oil, of course, there will go pro tankers. Like, if we have all this processing in Malacca and so on, then of course, we're going to have the tanker actually loading the oil and then travel to the destinative area. And of course, this is another work job for the Petronas marketing, where we do the arrangement for the buyers, and then the tankers will come in and load the oil. Some of the processing of storage of the oil here actually is from the floating storage near the platform itself, where the oil being pumped to the floating like a ship, or like processing floating vessel, where when they process, they can store to about 1 million to 2 million, or then the tanker will come in and load from the floating vessel offshore, which is at site. So once you have finished with your midstream, you're going to go to downstream. This is where the refining will be happening. So this is where you're talking about all the refining of the oil. But for gas, for gas itself, sometimes it goes straight to the to the industry, petrochemical plant, where it will convert it to fertilizer, to the resin, and even for some of the processing to create helium, which is quite unique. That you can see in the Middle East, they're talking about Qatar and of course UAE, where they are trying to load all the fertilizer, the gas through the channel, but it's going to be difficult now because of the war, and the oil price is picking up because of the issue with Iran and US war. Okay, so this is about upstream, midstream, and downstream. So for our case here, we're talking about mostly in upstream sector, where most of the job that you are interested in will be more discussed over here. Okay, the next one is let's talk about the global industry, so that you know the impact of the global to our local industry. So for the global industry, we can see that the value of the utilization of fund in within in the industry itself, the upstream especially, is about 4.8 trillion US dollar. You multiply by 4, it's going to be about 20 trillion ringgit. And then of course, currently it's seen that it's growing up. So we know that even because we're talking about all the renewable energy coming in, but still the oil and gas is picking up to show the importance of or the easiness or the simplicity of oil and gas compared to the renewable energy is still a requirement. So we can see a trend picking up about 5.5%, and it's expected to reach 6.43 trillion by 2030. So in other words, the trending of oil and gas industry is on. So the expectation that oil and gas will drop because of the renewable energy actually is not seen as a reality yet. So still we're talking about the oil and gas start to grow even up to 2020 and so on. So production investment trend, you can see the growth going up. Especially covering up North America, they always discover like the shale gas, and then they're talking about the deep water. In the Middle East, they go into deeper zone. They have more hydrocarbon recovered. Soviet Union, they have the Arctic region where they explore more and they discover gas and oil, mostly. So you can see that the demand for hydrocarbon is high. So the delivery or the supply is also going to be matched up with that. So that's why we can maintain quite a good price, of oil, because the supply and demand seem to balance by itself naturally. So you see the capex for global upstream, it's going to be for 2025. Building capex means building up platform and so on. It's about 420 billion, but it's slightly dropped because of the technology, and especially when we talk about the new venture actually coming up from the deep water. Deep water actually using less steel because they're using the subsea completion, subsea wellhead. So the capex is slightly lower lah. So this is mostly the trending that we can see. But the rebound itself is expected to be go up because of the more movement of oil from the new project. especially on the gas. So we can see that the world actually is coming up to the gas requirement because oil actually become less and less, but the discovery of gas is coming back higher and higher and more successful throughout the world. So for the strategic shift in technology, you can see that because of the demand of this gas and then because of the cost is increasing, we need to really have a shift in the technology to be able to really reduce the cost of oil discovery. So by reducing the cost, we balance out with the increase in the services and the expenses, capex and opex. And then, of course, at the same time, it gives us a better profit for the oil with the better technology. You can see that most technology coming up actually more talking about seismic, the high resolution seismic intelligence, the engine drilling itself, and the subsea production system. They help to reduce the capex of the oil and gas exploitation. Okay, of course, as I mentioned before, the artificial intelligence will help us in a lot of the seismic processing, the maintenance program, and so some of the drilling activity that can be more doing on fully automated version of semi-automated version. They help us to really reduce the human error. So the energy transition actually we're talking about. Of course, the challenging now is actually we're talking about the carbon capture. You can see the ozone being damaged quite significant in the current, I think, last decade. So even there's a push for us to really make sure that we release less CO2 to the gas, to the atmosphere. So most country around the world, especially even in Malaysia, we have the Kyoto Protocol where we're talking about reducing the carbon release, and this is part of the campaign carbon capture and storage that we try to really capture the CO2 and try to store it somewhere else or inject back to the reservoir, or to the depleted reservoir or some other features. So that's more or less the global industry picking up. That's the conclusion. And of course, the value chain itself for oil and gas, you can see how the support itself. Well, we're talking about the oil and gas is actually a capital intensive, very dealing with money, a lot of capex, and then of course involved with technology, but technology try to save the cost itself. And oil and gas involve high risk, high reward. So in other words, you had spent so much of the risk of spending money, but the reward is high as well. So this is the industry that we call it high risk, high reward. So it's involved money and technology. Of course, you can see that they have the upstream sector, the midstream sector, the downstream sector, but most of the high risk actually coming up from the upstream. But of course, the midstream also have the risk in terms of how the design should be able to contain the pressure and all the stresses into the corrosion and so on. And downstream is about marketing. I was talking about delivery. So talking about the shipping, the war itself, that can going to be a problem. The refining, some refining is aging, so they have to rebuild again, and rebuild normally takes about 3 to 5 years. So it's going to be quite, then takes time for everything to really come to effect. Vertical integration is talking about how the oil company behave when planning for their we call it business strategy. Vertical means that talking about from the upstream, midstream, and downstream, where they try to cover as much as possible. For Petronas, I think initially we start with only the upstream and very small amount for the midstream for exporting and of course processing. The downstream itself is quite not significant. But now Petronas covering all the sector of upstream, midstream, and downstream, where we are talking about having the plant, huge plant. We have especially like the storage. Bintulu plant is huge, and then we have all this Kertih refinery. We have Miri terminal, and then we have Labuan. We have of course somewhere in Kota KK as well. Refining. So we're talking about Petronas handling quite a huge activity for upstream and downstream in terms of the midstream. Okay, ecosystem means that professional involved in the oil and gas itself is going to be very extensive. We're talking about professional, the expert, and even all the research. Actually, is quite popular in oil and gas because we know that the moment you find something new, the market for your technology become high demand, and you can then there's going to be a big profit for all for this company that dealing with research, R&D. And of course, for the support services itself, you can see that we're talking about special services for all field services, which is by the third party. They're talking about the drilling services, completion, the logging, the cementing, fracturing job. All these services actually provide the support to the oil operator. For Petronas, actually does not cover all field services. They only manage and they only do the planning and monitor the execution of the project, but most of the support services actually is done by third party. Of course, at the same time, Petronas we hire a special consulting company to do EPC for a project. For example, they discover the field, and they want to start doing the processing, and of course the building the platform and the pipeline. So the EPC is a contractor, third party contractor that will do the design and procure all the materials, the steel, do the construction, and then of course they're going to do all the pipeline as well with the different. But EPC itself actually a design company. But of course, once they come up with that, of course the all company will start to really go to the tendering process to ask for the construction of the platform, the midstream pipeline, and of course it's going to be another type of service company. At the same time, as you know, that since the oil and gas is booming up, there's a lot of steel requirement, there's chemical requirement, and a lot of some of the consumables. So equipment manufacturing become very active. So you can see that most of the equipment manufacturing is building up very vastly. Currently, we can see that China is actually coming up with a very huge manufacturing in terms of steel, in terms of all the consumables. They do a lot in terms of supporting the oil and gas, and of course that give a challenge in terms of the quality. But it looks like quite recently, China products seem to be improved a lot since they are hiring most of the expert from US, from the Europe, to help them to maintain the quality so that they can have a good share in the market for oil and gas. At the same time, as you know, we when we have the oil and gas, we need to do the certification for the equipment, for certain installation, So verification and certification become another area where we're talking about uh, certified body to approve your design, your whatever you have done in terms of the installation, to make sure that the asset is safe and reliable. So that will part of the insurance coverage, because insurance we need all those requirements that you must be properly certified. Then you're entitled for your insurance coverage in case of any disaster. So you can see the total ecosystem of this oil and gas is huge. Okay. So let's talk about Malaysia oil and gas, which is another interesting story. Because once you know about the oil and gas in Malaysia, it will help you actually in terms of try to understand the opportunity to work in oil and gas and which area. So Malaysia oil and gas actually is a mixture. Overall, you can see that Malaysia, we have been quite matured. We have started drilling in Malaysia, I think in 1940s in Shell, in Miri. And of course, for Peninsula, we have the ExxonMobil coming in Peninsula Malaysia in the year of, I think, 1960s. Yeah? So which have been quite for some time, and overall our revenue have dropped 17%, to 260 million. Of course, the profit declined by 18%. I think for this 2025. The drop actually because we actually we have the advantage of the oil price about $80 before, but I think because of the supply coming up from the Middle East, which is Kuwait and of course Iran itself actually. I think of course I think even Soviet actually discovered quite a few field. US because of the demand. That's why. We can see that the drop in oil prices is because of the supply is more than the demand. So with $69 currently, I think we're talking about the drop, because the oil price become the big impact in terms of the revenue of each oil company. So you can see that because of the war in Iran, the oil price going up to 90, up to $100, but it's quite temporary. So the moment I think they have a much more stable situation in the war, in Iran war, I think the price will start to go down to 65 to even 69 again. So that's about the issue that we have. I think we need to increase production to be able to maintain our profit. Otherwise, it looks like currently it's declining in pattern. So in terms of the issue, Petronas hopefully announced it tried to reduce its dividend to the government. You know, so to 20 billion for to year 2026. I think we have Petronas have been given quite a higher number of this dividend to government. Recently, I think more than 14 billion actually last year. Hopefully, I think because of the situation with the declining of revenue, Petronas need to expend more money in terms of building up more, project overseas. So I think this is the intent, I mean the will or the requirement, I mean request from Petronas that the government will start to have less dividend lah for year 2026. So at the same time, you can see that Petronas also, they retrench or they take out about 5,000 employees, reduce the workforce. But actually, the 5,000 employees actually not the staff itself, the permanent staff, and mostly the contract staff, a short-term based, short-term consultant, which is being asked to to take off lah. So they reduce force by 5,000 but not on the key permanent staff lah. So it's much more misleading information from the news. Okay, now let's go back to the how to understand the 2025 performance of Petronas. You can see the upstream and gas and marine. Actually, our transportation of gas to Taiwan, to Japan, and to Korea. I think that's quite a lot. Profit of 20.9 billion for 2025 last year. Upstream activity, we're talking about exporting the oil from the field. I think that because of okay, it's going to be much higher if the oil price is better, but it looks like about 26 billion the income. So just imagine that with this profit, and then you have to pay the government of 20 billion. So just imagine that, almost half of the profit from Petronas go to the government. So this is where Petronas try to really reduce the request not to really, reduce their profit for their new project. But Petronas government have to accept the situation that we need to grow. Petronas need to grow. Okay. And I think for the drop itself, this is for the Malaysian upstream. So what is the strategy for Petronas? Petronas see that we need to concentrate on gas because we have seen that gas demand is high. We have more customers, from rather than Japan, Korea, and Taiwan. I think we are talking about more from the African side to export our gas. So based on this, study, we see that the drop is about 3.2% of the production overall. So overall, what happened actually when we talk about 2.4 million barrel per day from Malaysian side, actually it's quite confusing because actually what happened, the 2.4 million barrel, actually we have producing oil about 600 to 800 thousand barrel. So but 6 to 800,000 barrel is on oil. So the remaining 1.6 million actually is equivalent to gas. Recently, we discover a lot of gas from from Sarawak, and then that it will boost up the equivalent barrel. So that's why, according to the report from Petronas, actually we are producing a million barrel, which is I think quite a high number. Then we should be able to become the OPEC member lah, to be able to produce more than 1 million. But so far, we have yet to be accepted as OPEC lah. Even I think we are not interested to be OPEC. So for the first half 2025 compared to 24, I think is the upstream, the export of oil and gas become the main profit driver, about 20 billion per year. Of course, based on the strategy, we can see that what happened to the scenario in Malaysia, we have a steady production target. So we want to make sure that we sustain the production of 2 million barrel equivalent. So equivalent means that we have to convert the gas volume into barrel, so that it become much more comparable, easier to understand. So that's the target of Petronas, to maintain 2 million barrel of oil per day. And of course, to maintain that, to have, of course, our production is declining, so we need to have a more discovery for the new field. So we have gone through the deep water exploration for the last 15 years, but now I think going more and more and try to look for more areas. So currently we have areas like Langkasuka and Layang-Layang cluster in offshore Sabah and Sarawak, where we discover oil that will become another income for the country. But normally for development for all this field, this is gas field, it may take about 5 years before we can see the first gas coming up from that particular field. Normally take about 5 years for field development duration. So what happened for the growth? Major project like currently we have Kasawari, Jerun, and B14 constitute about 40% of the gas. So once we we produce from this field, we should be able to discover potential that we'll be able to increase, the production from these three fields. So it's always be a upside potential for this field after we produce and we study the area in detail. And one more game changer that the Petronas have come up is called Sierra. Sierra actually a joint venture, 50-50% between Petronas and Italian ENI. So what happened actually, ENI is have a big project in Kalimantan. And of course, they from this gas field, I think they started to produce highway and then discover more field, and they are looking for partners, to join them, because it's going to be a deep water, quite expensive exploration. So Italy, I think that's why they invite Petronas to be a party of it. So actually, it's quite interesting to see that how this going, because ENI is operating in Kalimantan, close to the Kudat area, so it's close to Malaysia. So the joint venture is actually a very interesting topic. It's quite a good environment that we be able to join with Italy, ENI, to be able to really do the total sharing of processing and marketing of this particular, hydrocarbon, which is gas lah, in this particular case. So if and I have Petronas, then Petronas will try to explore more marketing to market our oil, because we have a huge processing in Bintulu. But it looks like if NI come in, NI also have facilities in the Kalimantan side. So we should be able to share and try to organize the coordinated marketing for gas, with ENI. So the ambition of this Sierra, actually, from Petronas and ENI, they initially they have about 300 billion barrel, which is a gas actually, equivalent gas, coming up from the Kalimantan side, and our project is actually coming up from the Langkasuka and Layang-Layang is coming up too. So it will come up to quite a big volume for this particular. Now come back again. So you can see that major investment with Petronas and NI is cover about 6 billion credit facilities, and they want to invest 20 billion for the next 5 years. So of course, illegal one gas discovery for 5 trillion in Peninsular Malaysia going to be a part of the agreement. And of course, the Gangnos and Gaham fields in Kalimantan East actually from ENI will be part of the situation here. I mean the increment. Because Gangnos and Gaham field actually they have been drilling for the last 10 years, so they have discovered some field, but now they're talking about some additional discovery in terms of some other area that become a sub project for this Gangnos and Gaham field, adding up to I think about 10 trillion altogether for the NI side. So this joint venture, we hopefully will help our industry, our activity to go on together with NI in Kalimantan, NI staff. Of course, they have Indonesian working with NI to support their services like Petronas. Okay. So now from discovery to production is just to share with you how the process of this oil and gas coming up from the discovery of the oil and gas to until we produce and then do the marketing, sell it to the customer. Okay, before that, let's talk about the project life cycle. The project life cycle itself, you can see that we have the starting from the acquisition. So coming from the, we have the acquisition, which is we go, each, for example, one company or oil and gas company to explore into an area, they have to go to the government. For example, somebody from let's say from Africa coming to Malaysia, they want one African oil company want to actually bidding for the block in Malaysia. So they go for bidding, and then once they do the study, they go to the data room, correct all the data from Petronas, then try to study the area, and then try to go for bidding and ask for how much they want to bid for the area, for the block. Just like we renting up a piece of land. So somebody might post like 1 million per year, and then another company will offer 1.2 billion per year, and so on. So the winner will start to have the block, and when they have the block, they start to do the geoscience activity we go on. They start to do the seismic and so on. So they need a position like geophysics, petrophysics, and geologists to cover the acquisition and then the exploration part. So once they have done the exploration, they have to develop the field. And in development of the field, we have the petroleum engineer involved and some of the wells division involved in terms of the drilling engineers and so on. So you can see that the position of reservoir engineer, production technologists, petroleum economists, and the engineering team and so on is got high demand during the development stage. But during acquisition and exploration, mostly the geoscience group. Of course, in oil and gas, you see that some block is carrying in terms of the phase one, so it going like continuous. For example, in 2025, you have people concentrating on geoscience, and then 2027, we have people on development. So some of the oil company come earlier, so the overlapping is that it looks like a continuous requirement for all this position. So that's more or less about the project life cycle. So to do a development plan for the field, you can see that you had the position like still I mentioned about petrophysics, the assignment for people to do the work itself, like petrophysics is required, the geologist, this is geoscience. We start to have the reservoir engineer during the geological prognosis as well as some for pressure requirement. All this reservoir engineer will come in, and then production technologists is also part of this requirement for the corporation design and so on. And drilling engineer will come in, and facilities engineer to do all the assignment to complete the field development plan. So that's more or less the overview of the position and the assignment. Okay, let's look at the value because like quite the capital extensive for this oil and gas. So the step itself, in all the step that we do actually is going to be a decision making. So when you apply for the block, we spend about 10 million. That will cover, in terms of the data room, the consultancy fees to evaluate the block. And we have all the PSC agreement that we have to sign. And then we have some of the allowance have to give to the government in terms of having the signature, you call it signature bonus. We have to about 10 million spent just to apply for the block. And then once we have the block, we are awarded with the contract. Then we do the feasibility study to understand the regional area, purely to understand if there's any data before. Like Petronas, normally what Petronas do actually, Petronas will do the first 2D seismic, and then they will offer that 2D seismic as part of the feasibility study for the bidder. And when they evaluate, they have some information available. And of course, they will spend, sometimes they do another 2D or 3D seismic to confirm some of the interested area. And then they will spend about 20 million at that time with the study and then with all the economics analysis. And at that time, they will decide whether they want to continue or not. If they want to continue, they might be spending another 30 million to do the full 3D seismic and to do the proper analysis of the field, to see the potential and so on, do again the economic analysis. And then at that time, they already spent about 60 million. So if the study show that it's no good, they will drop the project. So they lost about 60 million. But if sometime what happen, they will keep the seismic and then Petronas be more or less offer to the other company at certain value. So that will reduce a bit on their exposure lah. And then sometimes Petronas will say that no, it's a burnt money, so going to be returned back to Petronas for the data. So this decision making, one they agree, they say they want to continue, then they will do the exploration drilling, which is about 30 million to 30 million per well. They had drill well. Of course, the exploration well, normally they go very deep with some of the program that talking about difficulties to handle and so on, because they go very deep, 50 million per well. And then if this from the drilling itself is dry, for example, what expected they have hydrocarbon, there's nothing, so they have to decide whether they have to drop or they have to drill another well. So if they want to continue to drill another well, appraisal well, to be able to confirm or even to improve their confidence of the block, then they have to spend another 60 million to do appraisal well. It could be about two wells, 30 million each, to do appraisal well on certain selected zone. And then by that time, they already spent 170 million. And another decision making will be made whether it's going to be a profitable or a potential project. If the project had the potential, then they're talking about doing the full development project where they spend quite a lot of money. It's going to be 600 to 1 billion just to develop a field, depends on the size. So in this particular case, they will spend about 600 million to develop the field, put a platform, drilling the wells, and so on, and having a PSO, flood plotting storage. So in total, they spend about 770 million. It can go up to almost 2 billion in terms of the huge gas project. Sometimes they spend about 2 billion in total. So this is more or less the understanding about how decision making will be made stage by stage until you're going to be a decision making to develop the field. You can see that it is a high capital expenses required. It's a high risk, high reward. So just imagine that once you develop the field, the profit that you from the economic we show that you can even have triple or even four times the amount of expenses that you have. So the profit is quite promising, we call it. Okay, for the module 2, exploration and geoscience, is going to go through quickly. So in terms of understanding the seismic survey being done initially in the upstream, in terms of the exploration phase, geophysics will be required. So this is special operation that required. No, mostly this is the geologist work. I mean, mostly geologists. I think UM and I think USM also have this project. I mean, geophysics lesson or the syllabus under geological department lah. So you can see how they do the seismic and then they evaluate through the computer system. They can do the mapping. This is the seismic result. You can see the interpret through the zone, but of course we can see a pattern because the vertical scale here is in time, millisecond. Because in seismic talking about the sound travel from surface down to each layer and then bounce back. So it's going to go to multiple layer, and with the sensor it can trace a pattern. Just imagine that this will help us. So this mapping is just like taking a picture. You can see there's a mountain system below below the surface of the earth. So we can see the pattern. So you see, it helps the geologists and geophysicists to understand the potential oil traps. And even if they can go to the 3D seismic, they can even plot it through a system from spatial simulation. They can plot in terms of putting it in terms of cells, and draw the pattern of the reservoir. So this is special skill by the petrophysicists and geophysicists, where they can map the earth and try to see what are the potential trap for the hydrocarbon and where is the possible source of the hydrocarbon, the source rock they call it, at the bottom. They're going through. They can identify what are the potential fault in this particular cross section from the seismic. And then once they have done that, they are going to construct a structure map. They will try to draw to certain layers cross section to, let's say, southwest to northeast. So northwest to, so it's like a cross. So they can see this is 2D, but you have another 2D, it become a 3D drawing. So like before. So this is how they construct the structure map. This of course the 3D reservoir simulator model that involves geophysics. Of course, this is going to be on the geophysics section. They're going to have this 3D framework modeling and so on, and then they have the geostatic modeling. All this under geo we call it geoscience area. So this is more or less extensive work. So if you are involved with this particular session, you can see the skill required in terms of understanding how to run simulator, how to run modeling, and how to understand all the statistics. Because it involves statistics as well in terms of understanding the high, medium, low, and all the probability like F10, P10, P50, P90, and so on. Okay.
Yeah, this one.
Okay. So should I read the question? So we try to to look into one question and see what's the question.
Fatini tanya, what software usually used for the mapping to geophysics?
Hmm. So I think that I will cover that as about the type of software. Normally it's a GNG software, and of course some of the geological section they still use petrol, which is also used from geological even to the reservoir side. So mostly it's petrol being used. Sometimes they have the geoframe. There's a lot of. I think I will cover that in my next section. When we go through the step. Okay.
This one
Hmm.
from Saifullah. Sir Latif, for the block application, who is actually approval body for the application? Is it NPM?
So in Malaysia, normally we MPM because MPM been trusted by the government or given authority by government to approve the block itself. So the tendering bidding process is done by MPM and the approval is also done by MPM. But approval have to go through government to get the final say lah. Hmm. Okay. Okay, done. So module 3, petroleum engineering. So petroleum engineering, you can see that we go to field life cycle again, but this time we talk about what are the function. So for acquisition, National Oil Company invite those bidders, and then of course bidders we try to have strategic partner because some of the operation, some of the investment in oil and gas is very expensive. So to reduce the risk of this particular area of that moment. So we ask for partnership. So in most cases, national oil company, for example, Shell, they try to, of course, Petronas, we ask for their portion. So Petronas, we put in 10% or 15% as part of the block ownership. And sometimes the oil operator also invite some other party. Like if this, for example, Shell, they will ask. Let's say Mubadala or maybe some other company from other region, for the same other for other country like even Pertamina be involved to be part of the partners or the partner. So it always be possible that in one block you might have 3 to 4 owners lah to distribute the share. As I mentioned, the oil and gas is going to be high risk, high reward. So to reduce the risk itself, you need to share those particular potential of failure lah. So and of course partner invitation, open block bidding is done and assignment by Petronas or in any case is MPM lah. Okay, and then when you do the exploration, you do the seismic acquisition, seismic processing, and you define the trap, the carbon source, and then at the same time, we confirm those expectation from the mapping. Confirm that through by drilling exploration well, and then we re-evaluate again to confirm the total worthless or how the value of that block is shared by drilling appraisal well. And at the same time, by having data from the appraisal well, like logging and coring, and do production testing, we have a better understanding about the potential of the field in terms of the production rate, in terms of the quality of the oil or gas, in terms of the contaminants, CO2, H2S, and so on, during the production testing. And of course, we're going to have the project economics to go through the potential of this block. This is the initial run of economics. before we start to do the development. So the economics we cover in terms of what kind of development strategy, in terms of the potential production per day, what is the field life, could be 30 years, 50 years, and so on. Of course, the PSC is only to cover up to 25 years. So the remaining possible attention is actually it can be requested to continue producing from the same field if the potential is continue. And at the same time, you go to development, you have to evaluate data from the exploration wells and appraisal. You assess additional data from the nearby field if possible, and then you evaluate risk and develop FDP. And then, of course, we're talking about what is the cost for for the field life, not only for your project, but you have to think about if you are going to have the PSC for 25 years, you have to think about all the maintenance of the platform, the production facilities, and all the potential shutdown, for the platform, the risk of having or price down or field failure and so on. So all these have been put into the cost so that we can understand the potential of the block and what is going to be remedial action to really solve the issues that will come in while we are developing the field or producing from the field. Depletion strategy is always important, and reservoir management plan (RMP) become important because depletion actually when we produce, we're going to reduce the volume from the underground, from the subsurface. So how we're going to maintain the pressure and how we're going to manage the depletion, because depletion means production is going to be dropping, you know. And of course, when we start to produce, we have to produce as per the reservoir management plan. We have to continue monitoring the field because this is going to be, a very sensitive area. We need to confirm, we have to make sure a very profitable business, optimum activity production. So we have to do the monitoring properly. It's done offshore with all these tracking systems, sensors, computer system, and so on. And of course, we are going to evaluate all this potential all the way. And of course, during production, as you know, reservoir management plan become very critical element of make suring that we produce the optimum. So the dotted line I shown here, actually the area where petroleum engineering will get involved a lot. Petroleum engineering covers from reservoir, drilling, production technology, and so on. Okay. And once we produce, of course, we have to abandon the well. Yeah, of course, at the field life, for example, the field life is about 25 years or 30 years. The production is going down, and then the revenue from production is too low to pay off the operating expenses of the project. That is not worth to continue. Then we have to abandon the field. And abandon total field is called decommissioning. They were talking about removing all the structures, go back to the normal situation. So we have to cut off and remove platform, and which is another big expenses for the oil and gas. Okay, so core discipline in petroleum engineering, you can see that we have reservoir engineer, drilling engineer, production engineering, and completion wells. So this is the area of petroleum engineering assignment. So objective actually, reservoir engineer understanding the physics and behavior of the reservoir. The engineer design and construct well bore so that it becomes safe for long term. For example, if we expected that the field will be up to 30 years, so we have to design the well up to 30 years. In some cases, if the production life is about 10 years, then it's not worth designing the well for 20 years or 35 years. So maybe just about a safety factor of another 5 years is good enough. Production actually managed to flow hydrocarbon from reservoir to surface. This is where we're talking about we're talking about potential flow to be continuous and be good in terms of optimal production, because whenever we flow the well, actually there will be a lot of contamination or a lot of damage to the reservoir while flowing because the movement of particles and fines to the profession area or to the sand face. Then this the production we drop, so we have to do something like the acidizing and so on to really repair the well. Okay, more or less that's the petroleum engineering. For reservoir engineering, this is the big part because reservoir architecture itself is huge. You know, from the general data, the general geologists, we talking about understanding the positional environment. All this will be information to reservoir engineer to plan for the management of the reservoir to make sure the reservoir will produce the optimum, and then any potential issues like depletion will be managed by certain requirement to to do secondary recovery and so on. So reservoir engineer will continue to make sure the no static total oil in place will be really captured, because sometimes they've realized that is stock actually higher than estimation before. Because when they do the monitoring, they try to do the analysis, do again the simulation. They can see that all this number can change either up or down. So they will, of course, everything that they have here will affect their production profile. Production profile actually the revenue for the company. And revenue means that you have to make sure that you maintain production as per plan. And if any shortfall, then going to be a more plan to drill. I mean, you feel well, new well to be able to ready, have this production profile maintained or as per the schedule. And all this actually come up with that one plan, a reservoir management in cycle to be able to maintain the optimal production of the field. But of course, from this side, you can see that all the input from the previous information will be used by reservoir engineers to really make sure that the reserve is fully utilized and drawn down or produced from the field. Okay, so I think we have a short break before go to drilling engineering. So I think I pass you to Ami. I think that's all I have for the time being. So I think let's just see the question before we go with our company, FAAZMIAR Marketing
Uh,
Academy.
okay, so we have another question from Azwani. Okay, hi sir, all and all. My name is Azwani. I have experience in production technician, quality laboratory, and process operations in the chemical plant industry. I would like to ask which career path would you recommend to progress into management or engineering, but don't have a bachelor degree in engineering, only bachelor degree technology management major in production and operation. Thanks, sir.
So I think the subject that you're talking about is more on the general subject, and it's not on oil and gas. But I think the knowledge of understanding the process flow of monitoring, like I mentioned, talking about the system flow of doing a job itself. Normally, become a junior engineer, you start to learn, even though it's a new subject, but with a basic background of physics and mathematics, you should be able to capture those knowledge as you go on. So even though we are from discipline which is not oil and gas, I think the best way is not going to be following your title, because your production does not really reflect oil and gas production, which is going to be different. So if you have the opportunity to go and do your study again in terms of going back to mostly you are going, if good result you may able to to attend this master program for petroleum engineering, then you start with the oil and gas lah. But even now, if you want to continue with your requirement here, actually company normally they will try to interview you just to understand your interest in oil and gas, how you're going to more or less position yourself, understanding the oil and gas during the interview. Then you'll be able to, even though your background is not actually directly to oil and gas, but the way you answer the question in terms of your approach, how to solve problems. So problem solving is very important. And then your knowledge about the new technology of AI, then we help you to continue to be absorbed as the staff of oil and gas. So like I mentioned, it's going to be interesting to to take a challenge and prepare yourself with more AI knowledge and interview, and then try to understand oil and gas through your research to be able to attend an interview and be successful. Thank you.
Okay, thank you. I hope that helps answering your question, Azwani. So we have three more. Okay, as a mathematics student currently doing my internship in the oil and gas industry, but not a big company, just a joint venture. Okay, I am really eager to expand my career. My question is, what position is suitable for me? What certificate should I have? Thank you. She is the mathematician student.
Yeah. Actually, mathematics have a very unique skill, because when you have mathematics skill, actually you should be able to use a lot in terms of programming, programming in terms of using the Power BI, and then you should be able to use Python itself. And then with the knowledge of mathematics, you should be able to design a proper algorithm, to be able to run. So you're going to work with the engineers, senior engineers, and they will tell you what kind of process they want you to design, and you have to get involved with programming. So you have to learn about programming. If possible, try to attend, gain your knowledge in terms of Python, Power BI, and some other programming languages, that will help you to use your mathematical knowledge and to be able to design well. Even you can build a simulation program that is requested by the requirement from senior engineers. So you're going to be a programmer. Thank you.
We have similar question. Amelia is a graduate of geoscience. What the best pathway for me to build career in petroleum industry?
Okay. You know that geoscience become very important element in terms of the field development plan. You're thinking about how to really accurately predict the oil in place or gas in place. So as geologists, I think there is another discipline called geophysics. So normally you try to more like gain the knowledge of geophysics, or you have some basic of geophysics. So it's quite important that you're going to more or less involve in oil and gas. If you are not able to be employed as geologists in the oil and gas, then you try to get involved with the third party contractor doing the AI on the geophysics analysis or seismic processing and so on. So this is where you start to really build your capability to help oil operator through your company that is dealing with AI processing of the food, because the service company we have the AI system, AI computer system that will help on companies. So by having the knowledge of that programming and understanding about the AI work on the system, your ability as a geologist will improve significantly to help the oil and gas. Thank you.
Okay, I think we have a very interesting question here from Naim. How important is field experience compared to technical software skills for mechanical engineers entering the oil and gas industry?
Yeah. For mechanical engineering, normally it's all hands-on. You need to have field experience, because the field experience normally dealing with routine. So, example, you go to do some maintenance, do some repair, it's going to be more or less like two or three equipment. So your knowledge of the system is going to be more or less consistent, and you are not improving a lot. But if you are dealing with, for example, rotating equipment, as mechanical, then there's going to be quite a lot, expansion of the equipment, because it's multiple list of, manufacturers, equipment type, and so on. So become a specialist in certain area is very important. So if you can be, you can concentrate on one particular element, especially on rotating equipment, it will help you to really boost up, and that is where the field experience will come in, because when you work with this kind of specialties, you're going to work with a special equipment, a special third party contractor that is dealing with that specific equipment. So you once you gain that particular knowledge, you're going to be very valuable for that company, and if you can serve global, you can go to everywhere in the world as an expert of that particular servicing by your company. So if you go and join oil and gas, what you do is just monitoring the process of repairing, or and then if you become for example, the mechanical engineer of the oil company, you just assign, contractors coming to repair the equipment. So your knowledge is not going to be that much if you are going under the oil company. So you are going to do more onshore work, in office work, rather than field side. But if you are interested to join the service company, then the field experience become important, and the reward is very good. for field operation. Thank you.
Okay, Afif Aiman asked like, he just finished his master studies in PE. Can you share which software skills that I can learn in order for me to land a job as petroleum engineer?
So the first thing is that you try to go to the third party under simulation. So this reservoir simulation become important, and when you do this reservoir simulation, you're going to cover a little bit of geoscience, it's a bit of production optimization. So your role will be covering very long during the field's life cycle. You have to cover from even from the FDP side up to the production optimization or the field development. So concentrate on reservoir simulation, where your skill will help the oil company to improve their revenue or improve their recovery from their reservoir itself. So reservoir simulation become a very challenging assignment and very critical for oil companies. So if you work with third party like Schlumberger or Halliburton, they have this very good reservoir simulation, then it become a very high demanding, challenging work. Thank you.
I think that's all the time we have for questions today. We do have a few more actually. Perhaps you can send me the email so I'll have Pak Latif to answer those questions for you. I believe it's like important questions too. Okay, so just send email to training@fazmia.com so I'll get Pak Latif to reply to your email. Okay, so basically, I think we already reached the end of the session. So thank you, Pak Latif, for an insightful and engaging session. Thank you to all participants for your active participation. I love that we have all the questions today. So basically today we journeyed through an entire oil and gas value chain. So you've learned from the industry, the fundamentals, and also the exploration part to the key discipline of petroleum engineering, facilities engineering, and the digital technologies that are transforming the modern oil field. We also explored a wide range of career pathways available in this dynamic industry, highlighting the opportunities for future engineers and industry professionals. So before you leave, remember, please complete our attendance and feedback form. So it serves as your attendance record, especially for those that are registered through the NTW portal. And participants who have completed that form will receive a copy of today's presentation. Okay, again, thank you everyone for your active engagement and thoughtful questions. We hope to see you in our next session, which is next week on Wednesday for behind the oil and gas project. So you learn about managing the FDPs in oil and gas, the project. You'll see the bigger picture of the oil and gas projects. So today we will learn how to get into it. Then you learn about the project next week. So until then, thank you. Stay safe and keep learning. Have a wonderful day. Bye.
Bye. I think the one question is talking about what is the difference between exploration and wildcat well. Actually, in exploration itself, there is going to be a, definition of wildcat and of course appraisal well. So, but people always mention that we do the first well, it's called wildcat because no information available. So you're doing something like the first test of the area, understanding about the reservoir. So it's called wildcat. But after wildcat, sometimes they go for the second exploration well, which is another new area. I mean, unknown area, but still because they have drilled in that block of what we call it wildcat well, being the first well. The second well they call exploration well. But if they want to confirm the situation of certain field on the same reservoir section, then it's called appraisal well, you know. So in general, exploration well cover wildcat exploration and of course appraisal well. So wildcat just mean of first well been drilled. So I think another question is talking about nothing much. Let me see. Okay. Okay, dah start. This is done lah. Okay. So let's continue. Hmm? Ada? Okay. Okay, now let's continue with the drilling engineering. So we have done the reservoir, we have done the geoscience. This is more on drilling engineering. Okay. Okay, for drilling engineering workflow, you can see even for drilling engineering, we have quite extensive work assignment. So this is the area where Cikgu actually involved a lot in terms of drilling engineering, where project initiation, well planning, cell, we go for detail engineering design of the well. And we go into detail in terms of how we should drill a well, how we should put the casing point so that we drill safely. Because the intention of designing a well is more towards that we should have a safe drilling when we try to manage pressure and of course temperature when we are drilling deeper and deeper into the earth. So sometimes you can see that we're talking about drilling normally about 3 kilometers below from the ground. Sometimes in some area we go to 5 kilometers, and I think in Russia they try to go to 20 kilometers below the ground to expect. But still, there is within the crust of the earth, not really going through to the center of the earth is more thousands of miles. Okay, so it's going to be just a short section lah. So involve, we have to for engineer, we also involve with procurement and logistics. And we are buying materials, engineering design, I mean the specification for material, and try to request for services. So it's going to be a lot of skill required when we're talking about more like 20 to 28 to 30 services in the oil and gas. So you need to know each subject and to be able to evaluate the process of these bidders to select the best for your project. And of course, when we talk about the pre-start preparation, before we drill, we have a lot of preparation to be done. Mobilize equipment, mobilize people, checking for the rig availability, and check the rig, and so on, and do all the inspection. It's been all done by third party, but we request for the services, to be ready to drill the well. So during execution, this is going to be the critical part, where you have to spend a lot of money, so try to avoid problems. And we apply a lot of technology to be able to solve problems by drilling. We do a lot of monitoring so that we can have some indication of potential failure. We start to take immediate action to solve the problem before it happens. And we do the evaluation of the well. All this by running logs is requested by the geologists, and we evaluate reservoir properties based on whatever available from the log. And of course, we are going to install completion while we complete when we drill the well to the end. We complete the well with completion equipment or completion string. And of course, before we pass the well to production, we have to do the integrity test, make sure it's all safe, it's all being tested. The well is safe to be handed over for production. And post drilling review is more towards like what we learn from the drilling, so a continuous learning process. So performance review will be more become important for us to understand what have been done good, what have done bad. So the next operation we continue to be improve ourselves. Okay, the next one is going to be a drilling management system, where in terms of drilling department you have the planning and budget section. We have the drilling engineering. So as engineer, normally you focus on all your division, what you're going to do. But of course, in general, you have to know all so that you are able to be more flexible, to be able to do planning. You can do engineering, you can do also account contracting, understanding how the basis of evaluating a contract. And then, of course, for doing equipment and logistic, you have to be able to, to have to identify what are the equipment that is being used in terms of the advantages, comparing different tools from two different suppliers, what are the advantages and disadvantages, and try to to make use it for your project so that you have less problem. Okay. And for drilling challenges, as you know, as a drilling engineer, there's a lot of problems when we are dealing with the Mother Earth. Now going drilling down 3 kilometers, 5 kilometers down the Earth, we are talking about temperature, pressure, chemicals, unstable formation, and so on. So whole problem that normally happen in drilling is loss circulation, hole cleaning issues, borehole instability, and so we stuck pipe because of borehole instability, because of some other issues. And then we have obstruction, maybe we might, while we're drilling, we lose certain stabilizers, we lose certain tools and so on. So it's going to be difficult. Hard torque and drag, because we're drilling in terms of directional well, we have this tech torque and drag that reduce our penetration rate. So it will take more time to drill, sometimes go through a much more problem to get stuck, with this high torque and drag. And while drilling, we also have potential gas kick, and we have well control issues. And this itself might take about 10 days to resolve. Like start pipe, it might take about 7 days, 6 to 7 days. So you're going to lose time if you have this problem and we are not able to avoid it. Because in our program, in our planning, we try to put in all the effort to reduce the issue. We should be identified the potential and try to solve the issues before it happen. And then, of course, we have another challenges like the equipment. The equipment we have, of course, the equipment is more is a rotating equipment. It tends to fail because of the bearing, because of the temperature. So you can see that all this issue will give you another time of failure. And for daily operation, it's about total operating cost, which is about 350,000 US dollar per day. So one day you lost 350,000. 3 days you're going to lose about 1 million US dollar. So you have to try to avoid problem. So waiting on something like waiting on weather because of bad weather and monsoon. So waiting for supply vessel which is late because of the issues with the engine, or maybe because you've been stranded at the port for so long, because for the clearance issues. So all this become additional cost to the project, to the well itself. So we have to manage that properly. And third party reliability, because every third party that we hire to do the job on the rig itself, we have issues. Sometimes the rig performance, the rig is not performing very well. They have issue with the mud pump, issue with the drawer, issue with, in terms of the equipment wise, in terms, the handling system and so on. So all these issues or by the third party servicer will add into another cost to the well. And that's why we normally allow 10% allowance for these issues. But if you go beyond 10%, we are going to be, have to answer to our management why we are not able to manage the operation effectively. So you can see the offshore drilling, directional well, we are normally we are not going to restrict, because in offshore situation, we try to assess some information here. For example, if development, we want to assess certain geological reservoir issues here, reservoir potential here, and then we want to assess reservoir potential here. So you need to drill a directional well. Otherwise, you always try to go vertical, because when we do the first well exploration, we want to be as simple as possible in terms of the well, so that we reduce the torque and drag issues and so on. But if you need to do a directional because of the requirement of different reservoir section, then you have to do a directional for exploration well. For development, we always go for directional because one platform can drill multiple well. You can drill 6 to even 20 wells from one platform by having directional well for different angle. So that's different. So since I start the nature of the environment of drilling, you can see it's not going to be a simple. It's going to be a complex, high technology that is quite required to be able to manage this system. We have subsea processing system here. We have subsea drilling template, a subsea control system. All these actually become quite a difficult situation of understanding, and only the expert, mostly you're coming from Europe or from US, they have all this proven technology. Even China is trying to come up with some of the equipment here. And of course, I think what happened because of the accuracy and because of the complexity of the design, the tolerance itself, mostly the American and Europe is providing the most of this equipment, special equipment for this new technology and new subsea system. So before, as a drilling engineer, the step is always that, you're going to have a depth and then you have a pressure. When you plot a depth and pressure, you can see the pressure increasing, And then, of course, you're going to have the pore formation pressure, this is pressure gradient, and then you decide the casing depth. And once you decide casing depth, of course, you try to plan the casing depth and then put in the depth and time. So you try to plan the well, whether how fast the well can be drilled. This is your expectation that you're going to drill this well as per plan, but this is the actual that happen. Normally, you're going to have problem with issues with equipment, with the with the rig, the party, and so on. So that's why sometimes you have some delay of that. So we're monitoring plan versus actual as a drilling engineer. For production technology, you can see that quite a huge assignment as well. First of all, production technology have to ensure flow insurance, what the drive mechanism, is it water drive, gas drive, or natural drive, and so on. And of course, the drainage point, they have to pick up the best drainage point with the reservoir and try to drain as much as possible. And they will become of the recovery factor, more or less. And of course, they have to maximize the production index, which is going to be how much barrel or gas, million cubic foot per day per PSI drop. This is the PI. Depletion strategy, whether going to be natural and so on, as I mentioned before, water drive, or maybe a depleted natural depletion and so on. Sand phase product completion is more like equivalent to the open hole completion, and how to be manage sand control. Artificial lift requirement, gas lift or whatever thing you consider in terms of pumping, ESP and so on, additional electrical submersible pump and so on. Production forecast become important so that we know which well is producing below expectation, which one is producing more. At the same time, we are most of production technology. We try to discuss with with reservoir engineer, try to think about the enhanced alternate recovery to improve the recovery factor of the field. So this is more or less the production technology strategy, how to maintain the gas demand. Okay, so let me see. For example, they will plan for the number of wells per the field. So one of the project in Petronas, they're talking about having a 6 gas producer, 1 vertical, then have 5 deviated wells, and then all these 6 wells is expected to produce about 900 million scf per day, which is about 120,000 barrel per day, which is huge platform. They mean huge revenue for the company. Okay, and at the same time, then we have this tubing size requirement by the production technology. They have to do the plotting of the from the ST result. They can plot gas rate versus the reservoir pressure to see when the pressure drop, the reservoir pressure drop. You can see what is going to be the gas rate. So the gas rate will reduce as the pressure drop, and this is the what we call it the flow of the. So this model is done by the production technology. So at the same time, they try to decide what are the best sizes of production tubing. So that they have the best production with less issues of water drop down and so on. So this is the job of the production technologies. So and then they're talking about the material selection. They will cover on the skill of how to use the table to decide on the material. For example, they have the CO2 and then they have a combination with H2S of certain percentage, more than 20 kilopascal for the partial pressure. It's less than 20, they're going to be a different steel. But if it is more than 20 kilopascal for the H2S partial pressure, then they have to go for the special chrome material. So for the requirement here. At the same time, based on temperature, the higher the temperature, going to be more difficult. That's why temperature become another factor to decide on the okay, on the requirement of nickel alloy or maybe some super 13 chrome, 17% chrome, and so on. Okay, so commercial design is going to be another function for this production technology. They are going to decide on the production itself in terms of the components for the operation, so that you'll be able to produce without any obstruction or delay or issues. And they design this well so that there will be less well intervention, so it gives more time to produce. For example, if there's any issues with for example, the valve is stuck and so on, with the flow, for example, one of the collapse uh, screen here, for example, then the production will be stopped. So they have to do the repair job, and it takes time. The net production time is being shortened. So we hope that each well should be produced 365 days a year. But with the problem, normally it come to about 300 days per year only, yeah, with 65 days on downtime or servicing and so on. So that's a challenge for production. For facilities engineering, this is much more on the facility side. You can see how complex is the in terms of the facilities design for the well. So with, for example, as you know, if it is a subsea itself, they have the pipeline, we have the subsea manifold to really gather information, gather production from each well. So subsea well, or for example, here they might have about 3 to 4 subsea wells. They have another 4 to 6 subsea wells produce and then to a line, then go to the manifold and go to the platform or even to onshore. It depends on what is the planning. So over here, you can see at surface, the work batch, we do the repair jobs. The FPSO, we actually talking about floating, production, storage, and offloading. So this also a system where, all the wells, the production coming out from wells and then going to the FPSO for processing. And then if it is oil, of course, the tanker will come in and of course load from the, from the storage here. So the storage about for example, 2 million. So most of tanker is about 1 million barrels. So they go, 2 tanker will drain the total storage of the field. So they will be continuously coming with tanker to offload the crude oil. But with this gas, normally it will go through shore, because gas is difficult to process unless you have the floating, they call it the LNG, floating natural gas, liquid gas. That is going to be a different storage or processing. But this is more or less, I can see another peso here. If it is a big project, we have more than, no, a few, more than one peso. If it is shallow water, there are going to be platforms installed, so you can have some of the production going to the platform. Processing will be done over here, and then it will be loaded to the FPSO, or it's going to be transferred to shore through the pipeline. So, okay. This is the receiving point of onshore. You have from offshore, all the pipeline going to onshore, they will process and then clean up some of the processing have been done. Half processing will be done offshore, and then will be another half being done by onshore before it going through a pipeline to the customer, to the refinery, maybe to the power station and so on. Okay, so at the same time, this is on the module 5, technology driven. Because the idea of this slide here is to show you how technology have been involved in oil and gas, so that you will be able to understand that, if you talk about, you have to go some research, understanding about the application, the benefits of this technology, that whenever you are requested to, to to explain during your interview, you'll be able to do that. Okay, so you can see that technology for the oil field, we have the AI and machine learning. This is very important for you to really get through, try to learn as much as possible and try to practice using all this AI and machine learning, whether you use ChatGPT or maybe Copilot or maybe DeepSeek and whatever and so on. You can have a dialogue. So you have a new tutor or new partner, engineering support expert is to help you to understand the process of whatever in your field. So AI, the ability to process large volume of data. So the importance of this information, AI machine learning, is based on data. So you have data, then it become worth it. If no data, AI will not be able to help you. So the more data you have, data collected from the well, from the fields, even from the seismic information to the drilling process, the data acquisition from each well, and of course, from the from talking about from the drilling information, all process is going to be a data, and we can use AI to really process information that to help us to understand the field, the challenges, and what are the what will be best practices have been done, and we're going to follow, and all the lesson learned. Hybrid modeling, talking about the system of, uh, combining physics is more like automation, self-calibrating models, where talking about if you do a processing, then you will try to really be intelligent enough to process the data and try to recorrect one of the outliers, so that you become much more better results in your conclusion. And then you have accuracy improvement in terms of come up with the conclusion of certain analysis. As one process control is mostly on automation. You have sensors, you have mechanism that automatically refer to the direction from algorithm from the AI, to be able to function and so on. They will help you to maximize production on the spot, other than human interference, which is very slow and then inconsistent. So mostly this process control will help you to be able to optimize the production. IoT, Internet of Things, become popular because IoT involve sensors, and the improvement of sensors cover a lot in terms of flow, in terms of temperature, pressure, and then even some of the contaminants, understanding CO2, H2S, sand control. All these sensors will help you to decide whether you are on the optimum side, whether by adjusting certain things you reduce the impact of sand, impact of the CO2 content, and so on. So all the sensing system here, real-time acquisition become important. In this particular world, you can see that everything become on the real time. Even during the drilling itself, in real time. Even during seismic survey, when they do seismic, you're going to be real time monitoring from the office to see the result immediately, so that they know whether they have to repeat the seismic survey on certain section, depend on the result that they monitor on the real time basis. When you do production, you also use the real time to understand the pattern and try to, if there's anything that become an obstruction of the line, then you react immediately. For example, when you do the processing, suddenly one of the separator is not functioning because of the sand accumulation is huge. Then you can detect much earlier. Then the process of bypassing, then remove the sanding inside the separator, it will be done almost immediately. Yeah. So that's why all this sensing equipment, the real-time requisition become very important in every facet of the exploration to the production of the well. AI, AI also become an interesting subject to discuss. So please explore the capability of this. Because by having the content from this slide, for example, you can start to explore from the AI itself the meaning of each subject, the difficulties of it, the challenges, and then the proposal or the improvement that you expected can be done, to resolve the issue. So ask the AI to help you to understand the issues. Okay. And then when we're talking about the technology given here, of course we have talking about continuation of the digital twin. I think if you talk about oil and gas, they will start with the digital twins. It's just like the to make understand about digital twins is that digital twins, that when you do a planning, it become one of the mapping of the system. So when you do operation, you have the real result. So you compare with what's your plan. So this is where you can see what are the deviation that happen, and at the same time you be able to react almost immediately and try to understand why it happened. And of course, sometimes you go back to the simulation, sometimes you go back to the record that we have, that if this thing happened, what is actually the story behind it. Yeah? So then the solution will be done. But of course, with AI, normally it will help you to, because of the database that you have, every component will be more analyzed, and then the AI should be able to propose whatever solution that it could be. Integrated system modeling is actually on the simulation side. That the simulation is improving a lot because of the computer speed that we have now. The processing is going to be much faster. For example, petrol before, when you talk about the system of reservoir simulation, normally it might take about 24 hours to get the result. But today, just between 1 minute or 60 seconds, you get the result of your analysis. Then you can reprocess those modeling almost like 10 to 20 times in a day compared to once a day before. So the computing speed actually try to help you a lot with the fast modeling. simulation, and then you can repeat again with different scenarios, and then find out with the simulator on the best result that you should be able to implement. So performance optimization also become important because for one information, for example, in drilling or in production, the what if scenario is more or less a system where we involve with the AI and with the control system that will adjust the requirement like the choke system, and then of course the whatever production that you need to do to be able, for example, slowing down on one well and speed up on one well to be able to maintain the optimal operation or production that will help you to optimize the production itself. So you can see that the performance with this computer system or with the we call it the intelligence system will help you to improve your revenue. Smart well completion become important because when we install a well, we try to reduce the intervention, and at the same time, the intelligent completion normally help you to stabilize, all the production through all the same phase, so that if one layer of a reservoir is producing more, and of course another layer is producing less because it's been suppressed by the high pressure or the the high production, then of course the system itself will be able to adjust so that you have the maximum production for the area. At the same time, on the reservoir management, which reservoir have to be produced more to be able to to have more recovery on each layer. So that's more or less on the smart completion. Green optimization technology is talking about all the CO2 and so on, so you get involved with that as well. Okay, so in terms of digital oil field, this is more or less, when we talk about oil and gas, especially when you are drilling, when you are talking about the production itself, it always will be about digital. Digitalization, we're talking about human intervention will be less. Mostly, we're going to have AI in monitoring the system. We human being, we more or less like approve or agree with the conclusion before the execution. Well, some area is fully automated, some area is semi-automated, some area that you need to be approved by human intervention. So all this digital oil field, you can see that the system of sensors going to the continuity of the communication between the sensors and the system, and then SCADA is actually the command center, which talking about taking the information, processing the information, pass it to the control system, activate the choke, the valve, and so on, to be able to optimize your revenue. So data management analytic AI is more like data gathering. And then when you do data gathering, sometimes it's being recompute and then go back to the optimization within the system, and then try to improve whatever is required to be able to produce the well to the best. Okay, of course, continuation, you can see that the oil field visualization is that once you have the processing, it's all done, behind the scene. So you need to see the result. So visualization means that you have to show on the screen on each element of the system in terms of the production system, to the sensing system, in terms of the what call the calibration or the sensitivity, the vibration, it all being checked to be able to to optimize your system and to have the best result. So schematic drawing is trying to show you what actually have the sensors in the SCADA system. We extract the information from the sensors, the AI will start to do work, and with the approval from the system integrated operating center, then you start to activate the control system to change the parameters of of the mechanics during the flow system of the platform lah. So with this system itself, you can see that we are going to have more or less a system that is run by this computer system AI model. At the same time, it go to do all the correction, and it looks like most of the modeling that have been done here have been proven to be working very well. So that's why we believe that all this system with the experience that we can trust the system to do its own, reduce human intervention, and put human more on the observation and verification system. So that's the function of more or less this digital field. So remember, we're talking about new technology all the time. Okay, so Now for drilling, what interesting about drilling, that is what FAAZMIAR is doing. Actually, you can see that for drilling, the drilling platform itself, we talk about real-time operating center. You just imagine that we have all the sensors from different, from the different zone. We have data coming from I see that this is it's not shown here, but anyhow all this coming from the mud logging system, the MWD system, the logging system, and then you have the mud lab system that putting in data, and then you have your system rig system. We're talking about the drawworks, all these drilling parameters on your top and drive system, all sensors are just coming out, input in the data, and then we collect to to your transformation. It go to town in Alpha and KLCC, where we receive the information, process the data, and then even some data go to the landing report, and then start pipe and widen, and then we monitor the control top and drag. So this is the real-time operating center that FAAZMIAR has been operated for the last 5 years with Petronas during our contract lah. So you can see a lot of activities that we know about drilling, and from here we optimize drilling operation, we reduce downtime, we reduce this unnecessary cost to the well. Okay, for daytime operation, I can see this the typical environment of the time because we have the screen, we have the geological part, we have the drilling string, then we have the lithology, we have some information about tow and drag, we have about drilling, the rig system itself, in terms of the mud pump monitor function, all the rotary system, the drawworks, and so on. It's a lot of information gathered in each particular real-time operating center. So even some company, we can have a mini RTOC where we monitor critical information, especially try to avoid issues, problems with the well. So we also help to some small company or some, because this Petronas have a huge RTOC center, but we can also have a mini RTOC, but still doing more or less the same function. Okay. So this is the last module on the structure carrier. So you can see that for this module here, you can direct role responsibility for an engineer. Actually, we're talking about having because I call it champion, because when you are in oil and gas, you want to be a champion that you can do a lot of things. That to be a champion, you have to have a knowledge, you have to have the understanding about the field. So you become, for example, a reservoir engineer. You try to focus on your skill of reservoir engineer to be able to understand the principle, the physics, and the logics behind it, and try to be able to explain to the people on site or even in the meeting room and so on. So you should be able to plan and design. This is in general. Design a project, manage drilling operation or drilling data, resolve complex problem and so on. At the same time, you should be able to manage contractors, understanding about their capability, their role and responsibility. And of course, you have to prepare report with support of the contractors to be able to give management a good understanding about the work itself. So daily work involve blend of office-based and head-on field work. So when you become engineer for oil and gas, you must have a field experience, because field experience give you a very good understanding about logic of doing things. And you learn a lot on the on-site because it's being done in steps, in proper order, and it give you time to think and about the logics of it. So that's why you need to have the on-site experience as well, field experience. At the same time, of course, you're going to learn a lot in the planning stage, offshore, onshore in your office, understanding about the engineering side, the planning side. So we have to know both to be able to be resilient, and you can work on both scenario, and each one support each other, because you work in the office with your experience offshore, you have to make a better decision. And of course, when you work offshore, when you with the onshore experience with your planning and execution, you are going to have the site operation to be doing the best, to maintain a good result. So in terms of typical, including project planning, optimization, data analysis, problem solving, collaboration to be done, because you're not going to be able to work alone. You have to work with your other partners, other division. If you are in drilling, you have to work with the geologists, with the reservoir, with production technologies, and of course with the facilities to be able to to understand what they have and what going to affect your planning. Okay, safety environment is always important. When you do a planning, safety and environment become an issue, not an issue. It become critical. For example, safety. Whenever you do plan, make sure that it's safe for your human for human life. You're going to be safe from the asset damage, and of course, importantly, you must avoid environmental impact. For example, CO2 become an issue nowadays. And of course, when we're drilling, we have this waste. The waste is actually the shadow waste, damaging waste. We also have radioactive waste. So it have to be really make a proper disposal, try to avoid the minimum impact to the environment. And for oil and gas, as you know, when we have drilling, we always have issues like well control. We are not able to control a well, we become blow up. Like the Macondo issues, they have, I think, about 2 million barrel to 3 million barrel being released to the ocean, and it damaged a lot of the coastal area. So that's the impact of doing the oil and gas. When we have disaster, you have blow up, you're going to damage the environment significantly. So in Malaysia, so far, we don't have any critical issue like that. Because what happened when we have, I think the geological or the direction of wind and our land actually is not going to be like in Sabah and Sarawak. It's going to be almost like the ocean current is flowing in parallel to the coastal area. But in Peninsular Malaysia, our monsoon, our wind is going to the coastal area. But since our project is mostly away from the coastal area, so most of the drop of, for example, diesel or oil will evaporate to the atmosphere before it reach to the coastal area. So we have that more or less some advantage lah, rather than having some disaster if there's any oil leak. I think in cases where we have oil leak from the pipeline in Peninsula before, we are able to shut in quickly from the platform. So the release about a few hundred barrel is still within range. Okay, graduate qualification. So to be able to become oil and gas industry, you need a bachelor degree, whether petroleum engineering or maybe some discipline of like chemical or mechanical, even some civil engineering, you should be able to come in. So what we expect actually, once you have the knowledge of physics and mathematics, should be able to adjust yourself to the oil and gas discipline. So professional licensing, as you know, as you go involved with this oil and gas, it's high tech. We got that at the same time, it always be high demand. And then, of course, the quality check is very stringent. So you need to be a professional engineer, and you register yourself to be a professional engineer, and then you can help in terms of approving. In UK, normally they ask to approve a drilling program. You need to be we call it a chartered engineer to be able to do that. That requirement is not come back to Petronas yet. But if Petronas request that all our drilling program, all our execution program, like when intervention, need to be signed by chartered engineer or professional engineer, then we are in trouble. Yeah, so you need to be ready for that. Because at the moment NPM revise their requirement for endorsement of critical program, then they might need chartered engineer or professional engineer to sign as the accountability. It depends on on insurance. Insurance asks for example the government to have that particular requirement, then we have to follow. So every one of you, hopefully you will start to get involved with our Society of Engineers. Our professional engineering, to be able to register yourself and qualify for the engineering for IR, hopefully to be able to help the company itself for their quality in terms of the personnel. As you know, for oil and gas, the career offers very strong financial rewards, very good money. If you are, for example, you go for a normal industry, you might be having about let's say 2,000 ringgit a month or 3,000 ringgit a month. For oil and gas, you might get about 3,000, but with bonuses and offshore allowance, you can go to even 5,000 to 7,000 a month for the young engineer. So it's a bit very attractive assignment for oil and gas. Opportunity work diverse location. For example, in Petronas, we have operation, overseas, like Mexico. We have sometime, like possibly now in Suriname, before in Sudan. So all this area, actually in Iraq, also opportunity for you to travel overseas. If you work with other company like PTTEP, they have project in Australia. They also project, in Indonesia, and of course. Some other field in Vietnam, so you can move around when you work with the oil company. If yeah, okay, and then okay, okay. I think we have time to look into the question. So graduate.
Okay, who wants to build a career in the petroleum industry? Would you recommend pursuing a master, or would it be more beneficial to focus on short courses to enhance my skills and meet industry requirements?
So if you are from a we are geologists actually. Yeah? For most geologists, normally they will come in to the oil and gas under the mud logging company. So you become the geologist or mud logging company, try to trace the drill formation, evaluate. At the same time, geologists, you go involved with pore pressure prediction. You will become the pore pressure specialist, which is another high demand for for the work for the drilling industry. And of course, if you are interested to go beyond with other criteria, for example, geologists will cover, like I mentioned, pore pressure analysis, the cutting analysis from the mud logging, at the same time the geomechanics. So all these elements become important. If you are expert, then you become a very important role to support the drilling itself, the drilling operation. But of course, your original work for geology is more on the geological modeling. So try to evaluate the oil in place and try to define the deposition environment and so on. So it become a big job itself. But if you want to go into more coverage in terms of production technology, drilling, reservoir engineering, it always be important if you try to attend a master program from either from UTP or even from Harvard, and they have some other university doing the petroleum engineering master program where they will teach you all the syllabus from GNG plus your PTEC, reservoir engineering, and reservoir simulation. They go to web testing, so many subjects involved that will expand your knowledge. So I think most of the full-time master program for petroleum engineering about 1 year, part-time about 2 years. So that will expose yourself to another discipline rather than just geologist. So that's what I can say lah. But geology itself has a big role because if all company normally they go for various exploration campaign, exploitation. For example, they go for block bidding in Suriname, they go bidding in Africa. The company start to utilize the geological and the geophysical requirement to do that. So as a geologist, I think you start to gain your knowledge of geophysics as well when you do the exploration campaign or analysis of the block and so on. So the role is still important, especially when you go and join a big company. The process of analyzing a project is continuous and non-stop. But for small company, might be they're talking about from upstream and talking about the geophysics up to maybe up to production. Then they might only complete the exploration, and then they mostly that they're closing down, but not they're closing down, but they minimize the manpower. So they shift to to mostly production technologies or reservoir engineer. So that is where you are lacking in terms of that knowledge lah. But you have normally company you join, normally they have that discipline to cover multiple projects. So your Y Simon as geologist is non-stop. Okay, thank you. Another question?
Itu tu nanti kita conclude dulu, nanti kita
Yeah.
jawab
Okay.
dua soalan dulu.
Okay. So let's continue. I think the next step, we're talking about the opportunity. This is more or less, I think, one of the slide. Okay, in terms of you can see in terms of the organization, you can the career track actually coming up from bottom. So, for example, you become head from reservoir side, you have the drilling side, production, petroleum economics, and then you have the finance side, which is not on BP side lah. So you start to FDP project manager. Of course, they have all the staff. Once you become manager of this particular group, drilling, and then of course you the next step is to go to the general manager position. And then for generation, then of course they're going to be a VP. So you can see that you continue to work in one oil and gas. I think you can reach the GM level after maybe 15 years minimum, and normally about 20 years lah. Then you have the GM position. But the bigger the company, then the slower you become because you have a lot of challenges to become the head. So normally for small company, it takes about 15 to 20 years to be able to become a GM. And VP normally it is more on those high IQ people with high connectivity, high networking lah. So if you're able to establish your networking earlier during the GM level position, then you'll be able to go to the VP side, Vice President side, and of course you're going to support the owner of the company lah. But one position that is important, you can see the HSC manager. HSC itself is unique. You're going to report directly under CEO because HSC become a priority in all company. So even you're a geologist, you can go and attend HSC courses, sometimes 6 months or 1 year. Then you'll be able to manage that to be able entitled to become HSC manager, even though you have the geological background or even some engineering background. Okay, so this is what we talk about the continuous learning journey. So I think that's all I have for the time being. So I think let's just see the question.
From Azwani.
Hmm.
Okay, hi sir, all and all. My name is Azwani. I have experience in production technician, quality laboratory, and process operations in the chemical plant industry. I would like to ask which career path would you recommend to progress into management or engineering, but don't have a bachelor degree in engineering, only bachelor degree technology management major in production and operation. Thanks, sir.
Hmm. So I think the subject that you're talking about is more on the general subject, and it's not on oil and gas. But I think the knowledge of understanding the process flow of monitoring, like I mentioned, talking about the system flow of doing a job itself. Normally, become a junior engineer, you start to learn, even though it's a new subject, but with a basic background of physics and mathematics, you should be able to capture those knowledge as you go on. So even though you are from discipline which is not oil and gas, I think the best way is not going to be following your title because your production does not really reflect oil and gas production, which is going to be different. So if you have the opportunity to go and do your study again in terms of going back to mostly you are going if good result you may able to attend this master program for petroleum engineering. Then you start with the oil and gas lah. But even now, if you want to continue with your requirement here, actually company normally they will try to interview you just to understand your interest in oil and gas, how you're going to more or less position yourself, understanding the oil and gas during the interview. Then you'll be able to, even though your background is not actually directly to oil and gas, but the way you answer the question in terms of your approach, how to solve problems. So problem solving is very important. And then your knowledge about the new technology of AI, then we help you to continue to be absorbed as the staff of oil and gas. So like I mentioned, it's going to be interesting to take a challenge and prepare yourself with more AI knowledge and interview, and then try to understand oil and gas through your research to be able to attend an interview and be successful. Thank you.
Okay, thank you. I hope that helps answering your question, Azwani. So we have three more. Okay, as a mathematics student, currently doing my internship in the oil and gas industry, but not a big company, just a joint venture. Okay, I am really eager to expand my career. My question is, what position is suitable for me? What certificate should I have? Thank you. she is the mathematician student.
Yeah. Actually, mathematics have a very unique skill, because when you have mathematics skill, actually you should be able to use a lot in terms of programming, programming in terms of using the Power BI, and then you should be able to use Python itself. And then with the knowledge of mathematics, you should be able to design a proper algorithm, to be able to run. So you're going to work with the engineers, senior engineers, and they will tell you what kind of process they want you to design, and you have to get involved with programming. So you have to learn about programming. If possible, try to attend, gain your knowledge in terms of Python, Power BI, and some other programming languages, that will help you to use your mathematical knowledge and to be able to design a well. Even you can build a simulation program that is requested by the requirement from senior engineers. So you're going to be a programmer. Thank you.
We have similar question. Amelia is a graduate of geoscience. What the best pathway for me to build career in petroleum industry?
Okay. You know that geoscience become very important element in terms of the field development plan. You're thinking about how to really accurately predict the oil in place or gas in place. So as geologists, I think there is another discipline called geophysics. So normally you try to more like gain the knowledge of geophysics, or you have some basic of geophysics. So it's quite important that you're going to more or less involve in oil and gas. If you are not able to be employed as geologists in the oil and gas, then you try to get involved with the third party contractor doing the AI on the geophysics analysis or seismic processing and so on. So this is where you start to really build your capability to help oil operator through your company that is dealing with AI processing of the food, because the service company we have the AI system, AI computer system that will help on companies. So by having the knowledge of that programming and understanding about the AI work on the system, your ability as a geologist will improve significantly to help the oil and gas. Thank you.
Okay, I think we have a very interesting question here from Naim. How important is field experience compared to technical software skills for medical engineers entering the oil and gas industry?
Yeah. For mechanical engineering, normally it's all hands-on. You need to have field experience, because the field experience normally dealing with routine. So, example, you go to do some maintenance, do some repair, it's going to be more or less like two or three equipment. So your knowledge of the system is going to be more or less consistent, and you are not improving a lot. But if you are dealing with, for example, rotating equipment, as mechanical, then there's going to be quite a lot, expansion of the equipment, because it's multiple list of, manufacturers, equipment type, and so on. So become a specialist in certain area is very important. So if you can you can concentrate on one particular element, especially on rotating equipment, it will help you to really boost up, and that is where the field experience will come in, because when you work with this kind of specialties, you're going to work with a special equipment, a special third party contractor that is dealing with that specific equipment. So once you gain that particular knowledge, you're going to be very valuable for that company, and if you can serve global, you can go to everywhere in the world as an expert of that particular servicing by your company. So if you go and join oil and gas, what you do is just monitoring the process of repairing, or and then if you become for example, the mechanical engineer of the oil company, you just assign, contractors coming to repair the equipment. So your knowledge is not going to be that much if you are going under the oil company. So you are going to do more onshore work, in office work, rather than field side. But if you are interested to join the service company, then the field experience become important, and the reward is very good, for field operation. Thank you.
Okay, Afif Aiman asked, like, He just finished his master studies in PE. Can you share which software skills that I can learn in order for me to land a job as petroleum engineer?
So the first thing is that you try to go to the third party under simulation. So this reservoir simulation become important, and when you do this reservoir simulation, you're going to cover a little bit of geoscience, a little bit of production optimization. So your role will be covering very long during the field's life cycle. You have to cover from even from the FDP side up to the production optimization or the field development. So concentrate on reservoir simulation, where your skill will help the oil company to improve their revenue or improve their recovery from their reservoir itself. So reservoir simulation become a very challenging assignment and very critical for oil companies. So if you work with third party like Schlumberger or Halliburton, they have this very good reservoir simulation, then it become a very high demanding, challenging work. Okay. Thank you.
I think that's all the time we have for questions today. We do have a few more actually. Perhaps you can send me the email so I'll have Pak Latif to answer those questions for you. I believe it's like important questions too. Okay, so just send email to training@fazmia.com so I'll get Pak Latif to reply to your email. So until then, thank you, stay safe and keep learning. Have a wonderful day. Bye.
Bye.